Well, hello. We'd like to welcome you to Mission Control Houston for the Digital Learning Network event where we're speaking with sixth grade students in Texas. With me is Amy Brezinski. She is a flight controller here in Mission Control, and we're going to talk a little bit about Amy's background before we take questions from the students. So Amy, what do you do as a flight controller here at Mission Control?
So as a flight controller in ISS Mission Control, I'm responsible for monitoring my system and performing actions with it. My system is the computer system. We call it the Command and Data Handling System. And my call sign is ODIN. Every discipline has a call sign. So my job in particular is to watch over the 48 computers on the space station that are running right now, and make sure that they're operating nominally, and then uplink software for all the other systems activities, and also get certain pieces of data down after those activities. So the computer system is responsible for interfacing with all the other systems to make sure that the crew can get data on those systems and that the ground can get data on those systems.
A lot of people may be familiar with how the space shuttle was operated, where the crew flips switches, and that's how things are commanded. But really, with the space station, the computers operate everything, and they interface with the laptops.
That's right. So there are a lot more computers than there were on shuttle, and we do a lot of commanding actually from the ground. So a lot of the flight controllers send commands, but I'm also responsible for making sure that those commands go through and the computers process them correctly. And then the crew can interface with the system through laptops on board as well.
And what kind of background led you to here to Johnson Space Center in Mission Control?
All started when I turned about 12. I saw the movie Apollo 13, and I kind of fell in love with human spaceflight and what NASA did, and it prompted me to continue studying space in general, and then also later on in high school and college, math and science and engineering. So I ended up going to MIT and studying aeronautical and astronautical engineering, and I got my bachelor's degree, and then I decided that I really wanted to get a master's degree and also co-op here at JSC at the same time. So I studied human factors engineering, looking at how people interface with autonomy, with semi-automatic systems. And then I co-opted here in the life support training group and the operations support officer group that do a lot of maintenance on station. And then once I finished my master's degree, I got hired on into the ODIN group to work with the computers.
And the co-op program is a great opportunity for students, we'd like to point out, because that's a great way that a lot of people get hired at NASA, is starting sort of as an intern while you're still in school at college. You can come here and spend a semester and work at different areas and learn about what it's like to work here before you actually come and hopefully get hired. How was that experience for you?
I really liked it, especially because you get to work in lots of different groups when you're a co-op. You can kind of try on the job and find where you would like to work most in NASA. And I had a feeling that I wanted to either train astronauts or be a flight controller. And so I got to do both of those things actually as a co-op, and then I decided when I got hired on full on that I wanted to be a flight controller. But maybe I'll get to train astronauts someday again.
And what kind of schooling did you do at MIT that brought you here?
Well, studying aeronautical and astronautical engineering, which is kind of a mouthful, so we call it aeroastroengineering for short. I got a lot of a basic education in engineering principles such as fluid mechanics, structures, thermodynamics, signals and systems, how computers work, and then I got to work on projects with teams. We actually, while I was at MIT, designed a modular wireless spacecraft, and we designed it, we built it, and we worked as a team, and that was very important because flight control is a team sport. You're never working on your own, you're always working with lots of other people who have knowledge in areas different than you, and if you take all of them and combine them together, you fly the space station together. So that experience of building a spacecraft in college really prepared me for the team environment here.
That sounds great, and I think we're ready to take questions from the students.
What is human supervisory control of multiple autonomous vehicles all about?
That's a good question. So that actually goes back to my days at MIT. I think somebody's been doing their homework. So what that means is When you have multiple vehicles, you can make them partially autonomous so they can fly themselves, because we understand how to do that with software, and so you can have them fly themselves, and you can have a person giving them high-level instructions, such as, go here, or go do that there. And so if you can give them high-level instructions, that means you can probably have one person supervising more than one vehicle. However, if you get a lot of vehicles and one person supervising, that can pose some pretty interesting challenges to make sure that the person is keeping track of all the vehicles, what they're doing, and if you're in a situation where there are time-critical things that need to happen, you need to make sure that the person can make good decisions about what the vehicles are doing. My research looked at was tools that I could provide to a person supervising high-level multiple vehicles in a time-critical environment, and giving them tools to help them make decisions for things that were going to happen into the future. So if something unexpected came up, to be able to give them a decision-making tool to change what the vehicles were doing.
Next question.
Why did you choose to become an ODIN, and who was your inspiration?
So I like to say that ODIN chose me. I wanted to be a flight controller, and at the time they really needed people to be an ODIN and to monitor the computers. So I actually ended up, ODIN actually chose me, but I really liked it. I work with a fantastic group of people. We do really complex things like changing out the software on the computers on Space Station. Actually, recently we changed out the hardware on the computers on Space Station. The Expedition 30 crew helped us out with that, and it was kind of like performing brain surgery on the space station. We changed out 7 computers, hardware, and almost half of the computer software. And that's very exciting. It's very complex, and it's very satisfying. It went very smoothly. In terms of my inspiration, I think I've been inspired by all the flight controllers and flight directors and astronauts that have come before me. And in particular, I had a very good mentor when I started here at NASA. His name was Colin Peterson, and he taught me a lot about being a good flight controller, and gave me a lot of lessons that I still use to this day.
Wait till we get the camera on.
How many computers are needed to run all the networks?
That's a very good question. So right now, there are 48 computers that are powered on, 41 computers that are running the space station systems and getting data and sending commands, and then we have 7 computers, laptop computers, that the crew can interface with the other computers, and they can send commands and get data from those laptops. So that's on an average day. Sometimes we can have more computers running, but it's quite a few.
Wait till the camera. Now stand up. Wait till the camera.
What do the multiple autonomous vehicles do if you lose communication with them?
So that's actually an interesting question, and one that I didn't look at when I was studying multiple autonomous vehicles, but I think that it's one that people will need to research later. I can tell you what we do when the ISS has a loss of communications. Those are usually understood ahead of time and planned. We aren't in contact with the ISS all the time, but we usually know ahead of time when we're not going to have contact with the ISS. And when that happens, we can't actually talk to the crew, and we don't get data down, and we can't send commands. But the space station, with all its computers, is pretty smart, and it can continue flying and monitoring its systems. And if anything would happen while the ground can't talk to the space station, the crew would receive notification, and they're trained to take action based on those notifications. So it's a pretty robust spacecraft. It can fly itself.
And if ODIN develops a problem, how do you fix it remotely?
That's a very good question. That's definitely a big part of my job, is if there's anything that happens in the computer system, I'm the person who's supposed to make sure I can fix it. You can have 2 types of problems in the computer system. You can have a software problem, or you can have a hardware problem. And we can actually address most of the software problems from the ground. We can send commands to fix the software. or we can cycle the software if needed. And for hardware problems, we have some ability to deal with that too, to address particular hardware problems. But sometimes if something would really fail in one of the computers, we might need to change it out with a spare we have on board. And so in that case, we would ask the crew to help us out, since we can't go do it ourselves here from the ground. And they're trained to do that, and they would go and they would take out that piece of hardware and put in one of the spares.
What is a typical day of work like on the International Space Station?
I think you just asked what is a typical day like on ISS. So I'll try to tell you what the crew a typical crew day is like. They're doing a lot of science right now. They do a lot of experiments, multiple experiments every day. They work Monday through Friday. And then when they're not doing experiments, they're exercising. They exercise 2 hours every day. And sometimes they also do some maintenance tasks for us. Just like your house at home, you've got to clean the space station, so they do some cleaning. And there's some regular maintenance they need to do to keep the systems running. And then sometimes if something breaks or something's not working quite right, we'll have them go take care of that as well and fix it or replace it.
What do you do for fun on the ISS?
So I think the thing that the astronauts do the most for fun when they have free time is look out the window and watch the world go by. If you haven't had a chance to ever see pictures from the space station, there's definitely a lot on NASA.gov, and pictures of Earth in daytime and nighttime are just beautiful. They take a lot of pictures, and you can see cities lit up at night. You can see major structures that humans have built. I think they can actually see the Great Wall of China. So they like to spend a lot of time looking at the Earth because they only get to look at the Earth while they're up there. But I do know that they do things for fun that you would do at home, on your weekends. Like they like to watch movies. They talk a lot to their family and friends. They can call them. They can also do video conferences. They read. They blog. They tweet. They write emails. So kind of similar things that you would do at home for fun.
A normal day, but in space, pretty much.
I'm sorry, can you repeat that question again?
So it's pretty much like a normal day, like on the weekend, except you're in space.
Exactly.
What are some things that you can say that you miss on Earth that are not in space?
So I think the first thing that astronauts say that they miss most is they miss their families and their friends. So when astronauts go up to the space station, they're up there for about anywhere from 4 to 6 months. So it's a pretty long time away from your family and friends, even though you get to call them and you get to see them on the video conferences. So I think that they miss that the most. I think that they also probably miss being outside. You can't open a window on the space station, so they probably missed fresh air and wind and rain. The weather's always the same every day on space station, same temperature. There's no rain on the space station, so they probably missed that too. And then they probably miss, things like certain foods that they like. They do have a very wide variety of food, but if you're, craving a certain type of food that you didn't pack for your trip, then you're gonna have to wait till you go home to eat it. But they do get a lot of different kinds of food. But I know sometimes they miss certain restaurants from home, from Earth.
How are accidents prevented in the ISS?
I'm sorry, can you repeat your question one more time? I didn't quite get that.
How are accidents prevented on the ISS?
Okay, it's a very good question. How are accidents prevented on the ISS? So one thing we do is we do a lot of planning and we do a lot of training and we do a lot of assessing the things that we're going to do on space station to make sure they're safe, because safety is our #1 priority. So anything that the crew is going to do, anything that the ground's going to do remotely, we take a look at and make sure that it's going to be safe. And then we also do a lot of training on certain activities to make sure that they are safe. And then if anything comes up that surprises us, like an emergency, we have procedures that we train a lot on the ground, and the crew also trains to know what to do, exactly what to do in an emergency. Kind of like you do in school with a fire drill. You know, you have fire drills, and you know which way you're supposed to leave and where you're supposed to meet and so forth. So the crew does that as well. They have a set pattern of what they do if there was a particular type of emergency.
Was there ever a time in mission operations when there was a critical life and death moment?
There have been times where there's been critical and life and death situations, and if you study space history, you'll learn that there have been times where we have lost astronauts. Apollo 1, for example, and Challenger in the 1980s, and Columbia not too many years ago. And we remember these times, and we learn from them, and we miss these people very much, and we're never going to forget them. We think about them every day. But again, you know, we try our best to make sure everything's safe, and we have these procedures and our plans in place. So we make sure that if there is a critical situation, we can react to it on the ground to help out the crew, and the crew can react to it appropriately. So it's something you never really want to run into, and we do our best to prevent those types of situations.
What breakthrough research findings have you found through the International Space Station?
Oh, this is a really exciting time because we are doing so much research on the space station. And this particular expedition, Expedition 30, they've been doing 35 hours a week of research on space station, and that's a record. That's a target that we set for ourselves, and we made that target. We could probably talk about all the different kinds of research for hours, but I'll focus on some of the human research, some of the human health research that we're doing. So one thing that we're working on is looking at doing experiments to try to come up with a vaccine for salmonella. So salmonella is a type of bacteria that you can get that can make you sick. It's a food poisoning type bacteria. And so it's possible that we could prevent that with a vaccine. So there's work on ISS being used to try to develop that vaccine. ISS is kind of a unique place because you can grow protein crystals differently than on Earth. They actually grow in a completely different structure. So we can use those protein crystals to try to come up with treatments for certain diseases such as cancer. And then finally, we have a lot of really cool robots on the space station. We've got a robotic arm, and we've got a robotic hand called Dexter. We also have Robonaut, and so we remotely operate those robotic arms and equipment, and that knowledge on how to remotely operate robotics can actually help people on Earth, doctors in particular, learn how to conduct surgeries remotely with robotic arms. So you could have a doctor in one city and a patient in a very remote area in a different city, or out somewhere where there isn't a city, and you could have the doctor conduct surgery on that patient with the use of a remotely operated robotic arm. So those are just some of the cool examples of the really neat research and technology development going on the ISS. It's a very exciting time.
Since we have space junk in space, is with more patients heading, has NASA come up with a way to clear the space junk?
So yeah, there is some stuff up in space. Some people call it space junk. We call it debris. It is a concern for the space station, so we haven't developed any ways to try to eliminate the space debris yet, but people do work on that. But what we try to do on the space station is we avoid it. So if we see that piece of space debris might be coming close to the station, and we have certain parameters that tell us what means close to the space station, we'll do what's called a reboost. We'll take the space station and we'll fire some thrusters, and the space station will move its orbit higher, and that will avoid the space debris. So we do a lot of tracking. We track a lot of space debris to make sure that it's not coming too close to the station, and then if it is, we do a reboost.
What is your vision for human spaceflight?
My vision is that in my lifetime, I will see humanity go back to the moon, go back to Mars, and maybe even have a space station someday around another planet. I think that'd be pretty neat. Excuse me. I really hope that I get to go into space someday, and I hope that all of you have the ability to go visit space someday, because I think it's a really cool place to go visit, and I think we're going to start seeing further and further exploration out from low Earth orbit, go to asteroids, and we'll learn more about our universe, and that's very exciting.
When the International Space Station starts to decommission and slowly lower down, how do you plan to safely lower it?
So the space station partners, all the international partners and NASA, have agreed to operate the space station until 2020, and maybe even longer. But someday we'll have to say goodbye to our space station. And what we'll do then is we'll use thrusters to kind of go in the opposite direction of a reboost. We'll use the thrusters to lower the orbit of the space station, and we'll bring it down in a very controlled, planned manner, probably in an ocean.
Have you ever wanted to go into the ISS?
Do the level?
Have you ever wanted to go into the ISS?
Yes, I would love to go to the ISS. I think it is one of the most amazing places off this planet, because I can't say it's on the planet. In fact, when people ask me, where, if you could go anywhere in the world, where would you go? And I'd always say, well, can I go off the world? Is that an option? It's really an amazing place. It's very big. It's bigger than I think a 3 or 4 bedroom house, and it's amazing that we built it. I mean, I remember when the first pieces were launched back when I was in high school, and it's been neat to see it continue to build up. So I would love to visit someday.
Since you're a coordinator, how difficult is it to handle the issues in space?
Could you repeat the question?
A bit louder.
Since you're a collaborative coordinator, how hard is it to handle the issues in space?
That's a very good question, and it's a very good way to describe being a flight control, a collaborative coordinator. So it's not difficult to work issues. We all learn how to communicate with people that do the different systems, and we learn about how our system, in particular my system, the computer system, interfaces with things like the life support system, the thermal system that keeps things cool, and the power system. So when an issue arises, we're all trained to work together to figure out what the problem is, and then what the impact is to the entire team and the space station as a whole, and the mission objectives and the crew, very importantly, and then what the workaround is. What do we need to do to try to fix the issue? And we practice this. We always say in our heads, we always think when we see an issue, failure, impact, workaround. And so based on that, we actually can work very easily together to come up with a solution to issues that affect multiple systems in a very collaborative manner.
When will
we be able to launch a spaceship from the ISS?
That's a good question. Right now, we don't have any plans yet to launch spacecraft from the ISS, but we do have some spacecraft that are launching to the ISS that are very new that are coming this year. You may have heard about one of them. It's called Dragon. It's a resupply spacecraft that's been being launched by SpaceX, which is a U.S. company. And we hope to see that resupply spacecraft visit us this month. And then later on, later this year, next year, we'll see the Cygnus resupply unmanned spacecraft visit. And that's another spacecraft that's produced by Orbital, which is another U.S. company. So it's kind of exciting because we're having new vehicles come to the ISS and getting more groups and companies involved with space exploration and ISS in particular.
I understand that was our last question from the students, so we'd like to thank the students for joining us today. We hope you learned a lot and you had some really great questions. Amy, did you have any closing remarks?
No, thanks so much for your wonderful questions, and it was very good to talk to you today.
Thank you.
Thank you.